Hello everyone, my name is Jiale Zhang. My research topic is directly controlling the perceived difficulty of a shooting game by the addition of fake enemy bullets. So let's get started. This is the brief outline of this talk. Let's firstly check concept introduction. Balancing the game difficulty and the player skill is a topic getting increasing attention for enhancing players' game experience. Based on the flow theory, where the difficulty level is far beyond the player's ability, the player will feel anxious. When the difficulty level is far below the player's ability, the players will feel bored. The current game difficulty adjustment mostly focuses on turning the parameters such as HP, time, which all contribute to real difficulty level to minimize the gap between the user perceived difficulty and actual difficulty so that the user can enjoy the game. In other words, the current strategy mostly tunes the actual difficulty and induces the change on perceived difficulty so that the gap between them is minimized. In this research, we investigate a novel way of adjusting the game difficulty. As the left-hand side figure shows, we want to directly impact the perceived difficulty with the fixed actual difficulty. Our research question is that whether or not it is possible to control the subjective difficulty perceived by a player just by adding enemy objects that visually present in the game but do not actually contribute to raising the real difficulty level. Next step is the experiment setup. To investigate our research question, we design a simple shooting game and introduce the fake enemy bullet. The fake enemy bullet just visually appears in the game but does not make real damage to the player. There are two types of fake enemy bullets. The first type is unreachable bullet. The second type is non-collisionable bullet. As you can see in the left video, unreachable bullet is shot to the direction that can never reach the player, but very close to the edge of the player character. In the right video, non-collisionable bullet does not make damage to the player even though they collide with the player character. Here is a complete demo of the shooting game. We have the player, which can be controlled with the left and right arrow key and use spacebar to shoot the target. To simplify the game, the player character can only move at the bottom edge of the screen. We have the enemy character flying to the edge of the screen, and one enemy object will shoot one enemy bullet. There are also some counters to report the performance of the player. Finally, each time the player has been hit, it will be respawned at the mid of the bottom edge and has 2.5 seconds invulnerable time. Based on our shooting game, there are 4 tests in our experiment. Test 1 and Test 3 are normal level without fake enemy bullet, and each of them is followed by a test containing one type of fake enemy bullet. Test 2 contains the unreachable bullet, and Test 4 contains the non-collisionable bullet. The players are asked to go through all 4 tests so that they can be kind of familiar with it. And then they will be asked to evaluate the difficulty of Test 2 and Test 4 based on the traditional Test 1 and Test 3. So what's the result? We have totally 18 players, 15 of them are men, 3 of them are women, and their age is ranged from 19 to 28. The right figure shows the evaluation on difficulty level of 2 different fake enemy bullets. We have adopted hypothesis test to answer our research question. We claim the difficulty level of the traditional test is 5, and the new hypothesis is that the average difficulty level of the test containing the fake enemy bullet is smaller than 5, and the alternative hypothesis is that it is bigger than 5. The results show that the unreachable fake enemy bullet cannot reject the new hypothesis, but the non-collisionable bullet successfully rejects the new hypothesis, which means it indeed increases the user perceived difficulty. In the end, the answer to our research question is that the addition of non-collisionable bullet can actually increase the user perceived difficulty, even though the unreachable bullet does not reject our new hypothesis, but it still induces the fluctuation of the user perceived difficulty. And we finally conclude that we have contributed to discover that the user perceived difficulty level can be a new dimension of the game difficulty adjustment. And our future work is to push the current game design into VR and AR. Thanks for listening.